A pleasant greetings to all. In this video, I am going to explain how to plot a root loci for a given open loop system g of s is equal to k into s plus 1 divided by s square into s plus 3.6 using analytical method and MATLAB method. First, I am going to explain the solution. First, step number 1. The step number 1 is find the number of poles and zeros for this open loop transfer function. Find the zeros and poles of this open loop transfer function. How to find out the zeros? Numerator polynomial equal to 0. We get the zeros of the transfer function. S plus 1 equal to 0 or s is equal to minus 1. So 0 equal to minus 1. And denominator polynomial equal to 0. So s square into s plus 3.6 equal to 0. S is equal to 0, comma 0. S plus 3.6 equal to 0, that is minus 3.6. So how many number of poles? There are 3 poles, 0, 0, minus 3.6. Now we got both zeros and poles. And what is the next step? Plot the zeros and poles in a graph. So I have to draw the graph. I am going to mark the poles and zeros here. This is sigma and this is j omega. Imaginary axis and real axis. Here 2 poles, have to mark the poles like this, zeros. And next 0, one circle, minus 1. And then poles, that is minus 3.6. And next I am going to explain the step number 2. Step number 2 is find the number of root loci. Number of root loci, that is the step number 2. Here number of poles are 3. Number of zeros are 1. So if poles, that is greater than zeros, so number of root loci is equal to number of poles. So number of poles are 3. So there are 3 numbers of root loci. And I am going to find out how many root locis are there. There are 3 numbers of root loci according to the number of poles. That is one of the root loci, that is starting from minus 3.6, and another 2 root loci are starting from 0. And n set open loop, pole set 0 or infinity. So first here I am going to find out the segment of the root loci. So you have to consider one point here. The point is P. So take this point. Towards the right, how many poles are there? There are 4 numbers of poles and zeros. So if any odd number of poles towards the right, so there will be some root loci exist. Even number of poles are there. There is no root loci exist in this point. Okay, I am going to rub this. And next, I am going to take the next point. I have to locate the point here. This is P. And towards the right, how many poles and zeros are existing? 0, 1, 0 and 2 poles. There are odd number of poles and 0 exists. And there may be a root locus segment, root locus between this point. And next I am going to consider the one point here. Locate one point here. And towards right, how many poles and zeros are there? There are 2. There is even number of poles. So there is no root locus in this point. So only one root locus between minus 3.6 to minus 1. And another 2 root locus that is starting from this open loop poles and ending at infinity. So 3 root loci. The one of the root loci that is starting from minus 3.6 and ending at open loop 0, that is minus 1. And second, another 2 root loci starting from open loop poles, that is 0, and ending as open loop zeros, that is infinity, and 0 to infinity. And next, step number 3. So these are how many root locis are available. And step number 3, how to find out the centroid. That is step number 3. So what is the formula used to find out the centroid? Centroid is denoted sigma A, that is sum of poles minus sum of zeros divided by number of poles minus number of zeros. Already we got the answer. Poles are 3 poles, 0, 0, minus 3.6. 0 is minus 1. Have to substitute the value 0 plus 0 minus 3.6 minus of minus 1 divided by number of poles are 3, number of zeros are 1. So minus 3.6 plus 1 divided by 2. So minus 2.6 divided by 2, that is minus 1.3. So this is centroid. After getting the centroid, next I am going to find out the angle of asymptote. Angle of asymptote. So how to find out angle of asymptote? That is equal to pi. The formula is 2q plus 1 divided by number of poles minus number of zeros into 180. First substitute q is equal to 1. So pi is equal to, q is equal to 0. 2 into 0 plus 1. Number of poles 3, number of zeros 1 into 180. 1 by 2 into 180, that is equal to 90. This is the asymptote number 1. So how many asymptotes? That is n minus number of p minus z minus 1. So p means what? That is 3 minus 1 minus 1. So total, 2 asymptote, p minus z, that is 2 asymptote. One is this asymptote 90 and second asymptote put q is equal to 1. So pi is equal to 2 into 1 plus 1 divided by 3 minus 1 into 190. That is 3 divided by 2 into 190. So 90, that is equal to 270 degree. So asymptote is over. Then next step, that is step number 5. Going to find out the breakaway point. That is step number 5. Breakaway point. So for finding out breakaway point, first of all write the characteristic equation. Characteristic equation. So what is the open loop transfer function given? That is k into s plus 1. So k into s plus 1 divided by s square into s plus 3.6. 1 plus g of s into h of s is the characteristic equation. And here h of s is equal to 1. Unity transfer function. Unity feedback. H of s is 1. That is equal to 0. So s square into s plus 3.6 plus k into s plus 1 equal to 0. So from this equation, what is k? K is equal to minus s square into s plus 3.6 the whole divided by s plus 1. So k is equal to minus s cube plus 3.6 s square divided by s plus 1. And next find out dk by ds. Differentiate k with respect to s. Then only we get, that is equated to 0. Then only we get the breakaway point. S equal to, here I have to use the u by v method. That is v du minus u dv divided by v square. So s plus 1 into, here one minus is there, s plus 1 into 3s square. Differentiation is 3s square plus 7.2 into s minus s cube plus 3.6 s square into 1. The whole divided by s plus 1 the whole square. So I have to expand this. So dk by ds equal to minus of s 3s cube plus 7.2 s square plus 3s square plus 7.2s minus s cube minus 3.6 x square. The whole divided by s plus 1 the whole square. So next, that is equal to minus of 3s cube minus s cube, that is 2s cube, 7.2, 3s square, 3.s. So minus 0.6, 3s square. So the value is 6.6 s square, then 7.2 s divided by s plus 1 the whole square. And next, what is the condition? To find out the breakaway point, put dk by ds equal to 0. So 2s minus and s plus 1 the whole square, that is multiplied with 0. So 2s cube plus 6.6 s square plus 7.2s equal to 0. Divide the whole by 2. So s cube plus 3.3 s square is, take s outside. So s into, or take 2s outside, so 2s into s square plus 3.3 into s plus 3.6 equal to 0. So what's the next step? S square plus 3.3 into s plus 3.6 equal to 0. Put minus b plus or minus square root of 3.3 square minus 4 into 1 into 3.6 divided by 2. So two answers are obtained. Here one of the answers already we got s is equal to 0. From this we get s is equal to 0. One of the value of s. Other two values are minus 1.65 plus or minus j 0.936. So there is no imaginary breakaway point. S1, S2. No imaginary breakaway point. So the only one breakaway point, that is S is equal to 0. This is the breakaway point. After getting the breakaway point of intersection on the imaginary axis. This is the step number 6. Point of intersection on the imaginary axis. On imaginary axis. For finding this, what I have to do, I am going to take the characteristic equation. So what is the characteristic equation? Once again I have to write 1 plus k into s plus 1 divided by s square into s plus 3.6 equal to 0. So how to find this? S square, cross multiply this, s square into s plus 3.6 plus k into s plus 1 equal to 0. So expand this, s cube plus 3.6 s square plus ks plus k equal to 0. So this is the characteristic equation. Next, apply the root stability criterion for this characteristic equation. So put s cube, here s square, s power 0. So write the coefficient here 1k, 3.6 k. So next multiply this. So 3.6 k minus k divided by 3.6. So that is 2.6 divided by 3.6. So it is the answer 0.72 k. So now 0.72 k is multiplied with k, that is divided by 0.72 k. Both are get cancelled. We get k. So 3.6.72 k, then k. Okay, next I have to take this row element, that is 0.72 k, equate it to 0. So if we equate this into 0, we'll get k is equal to 0. And for the sustained oscillation, what you have to do? Have to take the s square row. So write 3.6 s square plus k equal to 0. Already got the answer k, so 3.6 s square equal to 0. So s is equal to 0 here. So root locus branch does not intersect with the imaginary axis. From this we know root locus branch does not intersect with imaginary axis. Intersect with imaginary axis. And next what I have to do, I am going to plot the root locus. Root locus plot. For plotting the root locus, first I have to draw the real axis and imaginary axis. Then, so first have to put sigma and j omega. First of all, I have to mark the number of poles. Here one of the poles is double pole 0, 0. The next pole is minus 3.6. And next I have to mark the 0 also, that is minus 1. So how many root locus? So number of root loci is equal to number of poles, 3. So one of the segment of the root loci, that is between minus 3.6 to minus 1. And next root loci is from 0 to infinity and 0 to infinity. Next I have to mark the centroid, that is minus 1.3. Next I have to mark the asymptote. So asymptote, that is 90 degree and 270 degree. Straight line. Here this is 90 degree and this one is what? 270 degree. Asymptote. Mark the asymptote. After finishing this, have to mark the root loci. So see here, this is the root loci. And see, this is the root loci. It does not crosses the imaginary axis. So starting from 0 and ending at open loop infinity. So these are the two root loci, 0 to infinity and 0 to infinity. And see here another one root loci from pole to 0, open loop 0. So there are three root loci. This is the root locus plot. Thank you. And next I am going to explain using MATLAB. Now we are going to see how to write the program in MATLAB to sketch the root loci. So what is the step number 1? CLC, then clear all. Let's write num. Num is the numerator. So num equal to square bracket. What is the coefficient of s plus 1? Coefficient of s is 1. Coefficient of s power 0 also 1. 1, 1. Then put semicolon. Next den. Den equal to convolution. Here two functions, s square and s plus 3.6. So two functions are there. So convolution, then open bracket, then square bracket. So s square means the coefficient of s square is 1, s is 0, s power 1 is 0. 1, 0, 0. Then put comma. Here for s plus 3.6, coefficient of s is 1, coefficient of s power 0 is 3.6. 1, 3.6, close bracket, then put semicolon. Next write g. G means transfer function. G is df of open bracket num comma den. Put semicolon. Next command line for root locus, it is or locus of g. So this is the program to plot the root locus in MATLAB. Next open the command window and next click on new script. Then first put CLC, then clear all, and next num equal to square bracket 1, 1, close bracket, semicolon. Next den equal to convolution CONV, open bracket, square bracket, 1, 0, 0 for a square, close bracket, comma, 1, 3.6, close the bracket, again close the bracket, then put semicolon. Next, capital G, that is equal to transfer function of num comma den. Num comma den. Next, root locus command r locus or not r locus locus of capital G. Then close. Here put semicolon here and locus of G put semicolon. Then have to save the program, that is save as. R locus 1. Then save. Afterwards run. So see here, this is the plot. Already have drawn the same plot using analytical method. So in analytical, this is the pole. See this pole. And then the 0 here. Here 2 poles. And this is the root locus. Okay, have to click on here. System, what about the gain? Pole, all are given. So if you increase the gain 28.5, this is the root locus. Okay, here this is the increase of gain. And see, this is the decrease of gain. So pole to 0. So this is the root locus diagram for the given open loop transfer function. Thank you. Have a nice day.